aspiring electricians, here is some essential advice. Firstly, safety must always come first. Always follow electrical codes and safety regulations. Wear appropriate personal protective equipment, PPE, such as insulated gloves, safety glasses, and hard hats. Inspect tools and equipment regularly for damage. De-energize circuits before working on them. Secondly, study hard and practice. Attend classes regularly and take detailed notes. Study electrical theory, codes, and practical applications. Practice wiring, troubleshooting, and other electrical tasks whenever possible. Use hands-on projects to reinforce your understanding. Thirdly, develop a strong work ethic. Be punctual, reliable, and eager to learn. Ask questions when something is not understood. Be willing to take on new challenges and responsibilities. Maintain a positive attitude and work well in a team environment. Fourthly, build practical skills. Learn how to read electrical blueprints and schematics. Become proficient in wire splicing, termination, and circuit assembly. Develop troubleshooting abilities for common electrical issues. Gain experience with various electrical systems and components. Fifthly, seek mentorship and support. Find an experienced electrician to mentor and provide guidance. Join professional organizations like the National Electrical Contractors Association, NECA. Attend industry events and seminars to expand your knowledge. Leverage online resources, forums, and communities for support. Sixthly, stay updated on technologies. Keep up with advances in electrical technologies, materials, and tools. Attend workshops and training sessions to upgrade your skills. Embrace new technologies that improve efficiency and safety. Seventhly, get licensed and certified. Obtain an electrician's license in accordance with local regulations. Pursue certifications to demonstrate competence and enhance credibility. Consider specializing in specific areas such as industrial, commercial, or residential electrical systems. Eighthly, build a portfolio and network. Showcase electrical work through a portfolio of completed projects. Attend networking events and build relationships with contractors, clients, and other professionals in the industry. Establish a reputation for quality workmanship and professionalism. Ninthly, prepare for physical demands. Electrical work often involves physical activities such as lifting heavy materials, crawling in tight spaces, and working at heights. Stay physically fit and ensure comfort with these demands. Tenthly, seek continuous improvement. Embrace a mindset of lifelong learning and seek opportunities to enhance knowledge and skills. Stay informed about industry trends and best practices. Regularly evaluate performance and identify areas for improvement. Electrical safety is paramount. Always verify that circuits are de-energized before starting any work. Use a reliable voltage tester to confirm the absence of voltage. Follow lockout/tagout procedures to prevent accidental re-energization of circuits. Wear appropriate personal protective equipment, including insulated gloves and safety glasses to protect against electrical shock and arc flash hazards. Regularly inspect tools and equipment for damage and replace or repair them as needed. Maintain a safe working distance from energized equipment and use barriers or guards to prevent accidental contact. Be aware of potential hazards such as overhead power lines, underground cables, and confined spaces. Follow proper procedures for working with hazardous materials, such as solvents and adhesives. Report any unsafe conditions or practices to a supervisor or safety officer. Attend regular safety meetings and training sessions to stay up to date on the latest safety procedures and regulations. Electrical theory is fundamental. Ohm's law describes the relationship between voltage, current, and resistance in an electrical circuit. Voltage is the electrical potential difference between 2 points measured in volts. Current is the flow of electrical charge measured in amps. Resistance is the opposition to the flow of current measured in ohms. Ohm's law states that voltage equals current times resistance, or volts equals amps times ohms. Kirchhoff's laws are used to analyze complex electrical circuits. Kirchhoff's current law states that the sum of the currents entering a node is equal to the sum of the currents leaving the node. Kirchhoff's voltage law states that the sum of the voltages around a closed loop is equal to 0. Series circuits have components connected in a single path, so the current is the same through each component. The total resistance in a series circuit is the sum of the individual resistances. Parallel circuits have components connected in multiple paths, so the voltage is the same across each component. The total resistance in a parallel circuit is less than the smallest individual resistance. AC circuits involve alternating current, which reverses direction periodically. The frequency of AC current is measured in Hertz, which is the number of cycles per second. Transformers are used to increase or decrease the voltage of AC current. Electrical codes and regulations are essential for ensuring safety and compliance. The National Electrical Code, NEC, is a widely adopted standard for electrical installations in the United States. The NEC covers topics such as wiring methods, overcurrent protection, grounding, and equipment installation. Local electrical codes may also apply, and it is important to be familiar with the specific requirements in the area where work is being performed. Electrical permits are typically required for new installations, alterations, and repairs. Electrical inspections are conducted to verify that installations comply with applicable codes and regulations. Grounding is a critical safety measure that provides a low resistance path for fault current to flow back to the source. Grounding helps to prevent electrical shock and equipment damage. Bonding is the process of connecting metallic parts of an electrical system together to create a common ground. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect circuits from overloads and short circuits. Wiring methods include the types of conductors, cables, and raceways that are used to install electrical wiring. Conduit is a type of raceway that provides physical protection for electrical conductors. Boxes are used to enclose electrical connections and devices. Practical applications of electrical skills are essential for success. Wiring involves connecting conductors to devices and equipment. Wire splicing is the process of joining two or more conductors together. Termination is the process of connecting conductors to terminals on devices and equipment. Circuit assembly involves connecting various components together to create a functional circuit. Troubleshooting involves identifying and resolving problems in electrical systems. Common electrical issues include open circuits, short circuits, and ground faults. A multimeter is a versatile tool that can be used to measure voltage, current, and resistance. A wire stripper is used to remove insulation from conductors without damaging the wire. A crimping tool is used to attach connectors to conductors. A conduit bender is used to bend conduit to the desired shape. Blueprint reading is essential for understanding electrical plans and schematics. Blueprints show the layout of electrical systems, including the location of devices, wiring, and equipment. Schematics show the electrical connections between components in a circuit. Symbols are used to represent different types of devices and components on blueprints and schematics. A legend is provided to explain the meaning of the symbols. Electrical estimating involves calculating the cost of materials and labor for an electrical project. Factors to consider include the size and complexity of the project, the type of materials required, and the labor rates in the area. Bidding involves submitting a proposal to perform electrical work for a specific price. Communication skills are essential for interacting with clients, contractors, and other professionals. Be able to clearly explain technical concepts and answer questions. Listen carefully to understand the needs and concerns of others. Maintain a professional demeanor and treat everyone with respect. Time management skills are essential for completing projects on schedule. Prioritize tasks and manage time effectively. Be organized and keep track of deadlines. Avoid procrastination and stay focused on the task at hand. Physical fitness is important for performing electrical work. Electrical work often involves physical activities such as lifting heavy materials, crawling in tight spaces, and working at heights. Maintain a healthy diet and exercise regularly. Get enough sleep to stay alert and focused. Take breaks when needed to avoid fatigue. Mentorship and support can be invaluable for aspiring electricians. A mentor can provide guidance, advice, and support. Look for an experienced electrician who is willing to share their knowledge and expertise. Join professional organizations such as the National Electrical Contractors Association (NECA). Attend industry events and seminars to expand knowledge and network with other professionals. Online resources, forums, and communities can provide support and answer questions. Networking is essential for building relationships with contractors, clients, and other professionals. Attend industry events and meetings. Join professional organizations. Volunteer for industry committees and projects. Stay in touch with contacts and maintain relationships. Licensing and certification are important for demonstrating competence and enhancing credibility. An electrician's license is required to perform electrical work in many jurisdictions. The requirements for obtaining a license vary by location. Certification programs are available for specific areas of expertise, such as solar photovoltaic installation or electrical inspection. Continuing education is required to maintain a license or certification. Staying updated on technologies is essential for staying competitive in the electrical field. New technologies are constantly being developed, such as smart home systems, energy-efficient lighting, and electric vehicle charging stations. Attend workshops and training sessions to learn about new technologies. Read industry publications and websites. Follow industry leaders on social media. A portfolio is a collection of completed projects that showcases electrical work. Include photos, descriptions, and testimonials from clients. Use the portfolio to demonstrate skills and experience to potential employers or clients. A strong work ethic is essential for success in the electrical field. Be punctual, reliable, and eager to learn. Take initiative and be willing to go the extra mile. Maintain a positive attitude and work well in a team environment. Be honest and ethical in all dealings. Continuous improvement is essential for long-term success. Embrace a mindset of lifelong learning. Seek opportunities to enhance knowledge and skills. Stay informed about industry trends and best practices. Regularly evaluate performance and identify areas for improvement. The NEC is updated every 3 years, and it is important to stay up to date on the latest changes. Changes to the NEC can affect wiring methods, overcurrent protection, grounding, and equipment installation. Attend training sessions and read industry publications to learn about the latest changes to the NEC. Specific electrical calculations are frequently needed. Calculating voltage drop is important to ensure that electrical equipment receives the proper voltage. Voltage drop is the reduction in voltage that occurs as current flows through a conductor. Factors that affect voltage drop include the length of the conductor, the size of the conductor, and the amount of current flowing through the conductor. The NEC provides tables and formulas for calculating voltage drop. Calculating conduit fill is important to ensure that conductors are not overcrowded in conduit. The NEC specifies the maximum number of conductors that can be installed in a conduit of a given size. Factors that affect conduit fill include the size of the conductors, the type of insulation, and the type of conduit. Calculating box fill is important to ensure that conductors and devices are not overcrowded in boxes. The NEC specifies the maximum number of conductors, devices, and fittings that can be installed in a box of a given size. Factors that affect box fill include the size of the conductors, the size of the devices, and the type of fittings. Understanding motor control circuits is valuable in many electrical applications. Motor control circuits are used to start, stop, and control the speed and direction of electric motors. Components of motor control circuits include contactors, relays, timers, and overload relays. Troubleshooting motor control circuits requires a systematic approach. Start by checking the power supply and control voltage. Then check the components of the circuit, such as contactors, relays, and overload relays. Use a multimeter to measure voltage and current to identify problems. Ground fault circuit interrupters, GFCIs, are life-saving devices that protect against electrical shock. GFCIs are required in areas where there is a high risk of water exposure, such as bathrooms, kitchens, and outdoor locations. GFCIs work by monitoring the current flowing through a circuit. If there is a ground fault, the GFCI will trip and interrupt the circuit. Arc fault circuit interrupters of SIs are devices that protect against electrical fires. SIs are required in many areas of the home, such as bedrooms and living rooms. SIs work by detecting arc faults, which are small electrical sparks that can ignite flammable materials. If an arc fault is detected, the SI will trip and interrupt the circuit. Surge protection devices, SPDs, protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, and other events. SPD work by diverting excess voltage away from sensitive equipment. SPD should be installed at the service entrance and at individual pieces of equipment. Understanding the NEC tables is crucial for proper electrical installations. NEC Table 310.15b16 provides ampacity ratings for conductors based on their size and insulation type. NEC Table 250.122 provides minimum equipment grounding conductor sizes based on the size of the overcurrent protection device. NEC Table 430.250 provides full load current ratings for single-phase alternating current motors. NEC Table 430.251 provides full load current ratings for three-phase alternating current motors. Effective communication with customers and colleagues is key. Listen attentively to customer concerns and needs. Explain technical concepts clearly and concisely. Provide accurate and timely information. Maintain a professional and courteous demeanor. Collaborate effectively with colleagues to complete projects successfully. Time management and organizational skills are essential for electricians. Create a schedule and prioritize tasks. Set realistic deadlines and stick to them. Keep work area clean and organized. Maintain accurate records of work performed. Use technology to streamline tasks, such as using software for estimating and project management. Professional development is an ongoing process for electricians. Attend continuing education courses to stay up to date on the latest codes and technologies. Obtain certifications to demonstrate expertise in specific areas. Participate in industry events and networking opportunities. Read industry publications and follow industry leaders on social media. Seek out mentorship opportunities to learn from experienced professionals. Safety meetings are essential for preventing accidents and injuries. Conduct regular safety meetings to discuss potential hazards and safe work practices. Encourage employees to participate in safety meetings and share their experiences. Document safety meetings and track attendance. Follow up on any safety concerns or issues that are raised. Job site safety inspections are important for identifying and correcting hazards. Conduct regular job site safety inspections to identify potential hazards. Use a checklist to ensure that all areas are inspected. Document inspection findings and track corrective actions. Follow up to ensure that corrective actions are implemented. Lockout/tagout procedures are essential for preventing accidental energization of equipment. Develop and implement lockout/tagout procedures for all equipment. Train employees on lockout/tagout procedures. Use lockout/tagout devices to isolate equipment from energy sources. Verify that equipment is de-energized before starting work. Confined space entry requires specific training and procedures. Identify confined spaces on the job site. Develop and implement confined space entry procedures. Train employees on confined space entry procedures. Use appropriate personal protective equipment, such as respirators and harnesses. Monitor the atmosphere in confined spaces for hazardous conditions. Proper use of personal protective equipment is essential for protecting against injuries. Wear appropriate personal protective equipment for the task being performed. Inspect personal protective equipment before each use. Replace damaged or worn personal protective equipment. Follow manufacturer's instructions for using and maintaining personal protective equipment. Understanding electrical theory is essential for troubleshooting electrical problems. Use a multimeter to measure voltage, current, and resistance. Use a circuit tracer to identify the path of electrical circuits. Use a clamp meter to measure current without disconnecting conductors. Use a thermal imager to detect hot spots in electrical equipment. Electricians need to understand the principles of renewable energy systems. Solar photovoltaic (PV) systems convert sunlight into electricity. Wind turbine systems convert wind energy into electricity. Battery storage systems store energy for later use. Electric vehicle (EV) charging stations provide electricity for charging electric vehicles. Smart home technology is becoming increasingly popular. Smart home systems automate tasks such as lighting, temperature control, and security. Electricians need to be able to install and troubleshoot smart home systems. Understanding the principles of energy efficiency is important for reducing energy consumption. Use energy-efficient lighting, such as LED lamps. Install energy-efficient appliances. Insulate buildings properly to reduce heat loss and gain. Use programmable thermostats to control temperature. Electricians should adhere to ethical practices in their work. Be honest and transparent in all dealings with customers and colleagues. Avoid conflicts of interest. Protect confidential information. Provide high-quality workmanship. Follow all applicable laws and regulations.